I'm going to show you guys how to start out with a solid blank of pre-machined material. We'll do some Transform Toolpaths and some thread milling, so stay tuned. So let's go up to our wireframe, and I'm going to select a circle endpoint. My diameter will be 4.75, and I'm going to press enter, and this I'm just going to press O, or you can click up to auto cursor and click origin. My next hole I'm going to build will be for a 1 inch 1 1/8 12 UNF thread. So I'm going to punch in 1.025. And I'll press O again to get that to center, and I'll click OK. So now I have my blanks for my material. So I'm going to go up to my solids and click on extrude, and I'll select both of these circles. Now I want to extrude this so that it's 1 inch exactly, but I want to make sure that this is going to be below the Z level. So I'll go to my view and put on show grid. So this is showing that it's above it. So I'm going to click on this reverse all button. Now everything comes off of Z0. Click OK, and I want to throw on some chamfers on this. So we'll go back to solids, go to one distance chamfer, and I'm going to uncheck these two boxes, and now the only one selected is edge. So I'll click on these two edges, and we're going to set these at 0.0313. I'm going to create a new operation and do the inside bores. And these are going to be 97 thou. Now I'll click OK. And if I wanted to hide these, I could put them on a different level. So let's go to View and go to our Levels button. And now I have my Levels tab for down here, this Levels Manager. So I'm going to name this Solid. And then I'll create a new level. And this will be Solid Geometry. Now I'll click on these two lines or wireframe and then right click, and then down here it says change level. I'll click on that and click on move. Now I can highlight only my solid, and now that geometry is hidden for using later. You can also have both showing and click on your solid and then go to hide or unhide, and that will hide anything that's unselected. I'm also going to create a new tool level where I'm going to call this wireframe, top wireframe. Now let's go back to our Toolpaths tab, and we don't have anything in here. So I'll go up to my machine and select Mill Default. I'm going to click on Stock Setup, and I want to click on my solid mesh, and I'll select the new solid we've created. So now this allows me to use this as my stock. So it's already pre-machined on the lathe. I'll go back into tool settings, and I want to make sure that my assign tool number sequentially and warn of duplicate tools are available. Now I want to create my top wireframe geometry. I'll go up to my top view, and I can hide my wireframe or my solid. I'm going to use only my top wireframe, and you can see how these X's will show. The active level is going to be the one that has a check mark. So I'm going to unselect those. I'm going to go to my toolpaths, and let's start creating our wireframe. First thing I want to do is specify a radius of 0.9375, and I'm going to put that on the origin. Create another one, 1.4375, put that on the origin as well. Now everything is going to be working off center, and 1.9375. And that will be our origin once again. And these are going to be 1/4 tapped holes. So I'll specify them as 0.25. And I'm going to lock this button. So now it constrains it. And now I want to try and click on these lines, except it's not going to select. So what you can do is click on your selection settings and pick the quadrant option and then click OK. Now it'll ask you if you want to save, and now I should be able to select each quadrant. Now I want to put one on each of these and I'll click OK. Let's click on the Transform tab. Now I want to move some of these circles. So I'm going to go up to Rotate, and I'm going to select this one only. Now I want to set this at 18 degrees, and I'm going to increase this by 1, 2, and 3. Okay, now I'm going to move this. So then that gets rid of the one that I had prior. So I'm going to click OK, and I'm going to select the next one and do my end selection. I'm going to select 2, and these will be 30 degrees. Click OK, end selection, and we'll do another one. And we can do 1, and this will be 45 degrees. Now I have all my holes set in this quadrant. We're going to have 4 holes, or 4 sets of holes all the way around, but we'll use a Transform Toolpath. We're only going to do 1 quadrant. I want to build a slot on this section here. So let's go back up to wireframe, and I'm going to click this little drop down below rectangle and click rectangular shapes. Now I can select all round, rectangular. There's many different options here, but the one that I want is all round. I'm going to click on this top, actually let's click on the middle one here. So this is going to be the anchor point of where it drags. So I can show you here, you click and you drag from that point, except I want the center of that slot over top. So I'm going to click on the middle one and drag it out. You can see we haven't specified any options here, but I want this at 0.25 wide, and I want to have this 1 inch, but I also want to add a 1/4 inch, so 1/8 of an inch per side. So plus 0.25, and now you can see it spans over top. Now click OK, and that is my new slot. So now I want to create some center drilling operations, but we're going to use a spot drill. So let's go up to our toolpaths, go up to Tool Manager, and let's create a bunch of tools here. What you select as your filter will appear down here. This is your library. What you can do is create tools and store them, and then everything that you have here is stored for this particular job. So I'm going to create a new tool in my library here. I'm going to create a spot drill. It's going to be a 90-degree spot drill, and we're going to do 375. So 3/8 spot drill, and we can specify our feeds and speeds here. Now I'm going to say that this is an aluminum blank that's ready to go. 0.375 divided by 150. We get a chip load per tooth and a feed rate of 61. I think most of these options are good. So I'll finish, and I'm going to create a new tool, and I'm going to find a drill. So I'm going to change this to 0.201. That is the tap drill size for a 1/4 20 tap. We can go to Next and set our feeds and speeds here. 0.201 divided by 150. And everything else looks good. Create a new tool. I'm going to use a flat end mill. We're going to call this a 1/2 inch. click Next, and we'll specify 1200 surface feet per minute again. 0.5 divided by 150. We have a feed per tooth at 3/3 We have 4 flutes, and we'll click Finish. Okay, so we're going to go down to Tap, click Next, and we're going to set this at a 1/4 So you can also click these drop downs if you're not really sure or remember what the size of the drills are or anything like that. So we're going to go 1/4. You can specify if it's a left-handed tap, but this is going to be a right-handed tap, and we'll use a plug. So I wouldn't go much more than 500 RPM with the tap. The reason being is you need to have at least 3 times your pitch in order to accelerate and decelerate on older machines. Now this being 500 RPM will be able to slow down in enough time that it's not going to hit the bottom of the hole. But these are through holes, so we don't really have to worry about that much, but just make sure that you're not going like 10,000 RPM. So click OK. And the next tool I want to create is going to be a thread mill. So that's right here. And I want to create a unified national. There's going to be 12 threads per inch. The outside diameter is going to be 0.745. Our overall length, we can specify this at 4 inches. The cutting length will be 1.5. Shoulder length can be 1.5. Shoulder diameter will be 0.75. Our shank diameter will be 0.75. So it's going to look like this. We'll click Next. And we're going to specify our surface feet per minute at 1200. So we're doing aluminum. And our feed per tooth. Now this is going to be something that we're going to have to look at based on some certain parameters. So I'm going to flip over to OneNote, and we're going to take a look at the chip load per tooth for this multi-pointed thread mill. So we have 6 flutes. 0.004 thou 13. I'm just going to leave it at 4 thou per tooth. So let's click Finish. We're going to create one more tool. And we need a flat end mill, and we have to do that 1/4 inch slot. So we're going to set this at 3/16. So 0.1875. And we don't want any corners. We're going to specify that this is carbides at 1200, and my feed per tooth, 4 flutes. Sometimes you might have 2 flutes. Click Finish, and we are done setting up our tool. So let's click OK. Now, first thing I want to do is maybe spot drill all of these holes. So if I go up to 2D, you can go to Expand Gallery to see more options, but I'm just going to go to Drill. And I'm going to select these holes, and now you see how that has selected a quadrant. We might want to go back into these options and then press the Delete key to get rid of that. Okay, so now we have sorting options as well. We can click the selected order, or we can specify zigzag. Doesn't much matter. It's not going to be crossing a whole lot of things. It might come in handy when you're trying to jump over a wall. So whenever this is picked, or you can even do a window selection. So if I wanted to click and drag, I can have my points selected in the selected order. So I'll click OK, and I'll go to my tool. And let's select the 3/8 spot drill. We have a spindle speed. Now this is dependent on your machine. But I'm going to go down to my cut parameters, and I want to drill and countersink these holes in one shot. So I'm going to leave this on drill counterbore, and I'm going to add a dwell. I believe this is in milliseconds. I'm going to go to linking parameters. I'm going to set my height to 2 inches, absolute. I can use my clearance at the top, start and end of the operation, and this just allows me not to wrap it up 2 inches in between each hole. It just does it on the first and the last one. My retract, I'm going to specify at 0.1. My top of stock is 0 because this is already machined. And my depth. Now I'm going to set this at absolute, and I want a finish diameter of 0.375. So I'm just going to click OK. So that is the total width of my spot drill. Now I can lower it by 1 thou or whatever just to get it accommodated, or use a larger spot drill. I'm just going to check my planes, make sure it's all set to top, and then make sure I have my coolant set on. And I like to save my parameters so that I don't have to set these options again. They're all fairly close to the defaults. So I have my first spot drilling operation, and I'm going to name this. So I'll just click on this operation and spot drill. Now I want to drill out these holes, so I can just copy and paste this operation. And if I also want to set my comments in here, I can go back into Tool, which we have to go to anyways to select our drill. And we'll make sure that it uses the right feeds and speeds. This would be 250 and 0.201 divided by 150 will give us a feed rate of 12 inches a minute. Now this will be tap drill. I'll go to my cut parameters, and we're just going to drill right through, but we don't need a dwell. So we'll turn that off. We'll go to linking parameters, and I want to specify the depth of my hole. So I know that this piece is going to be 1 inch exactly. So minus 1 inch. Now I like to have a little bit of breakthrough, so I also put in minus 0.05. And I also have a tool tip. So this is going to be tool 1. So that will give you the actual tool tip length, or the point. So then I should be alright to click OK. Now if you wanted to verify, you click backplot here, and I'll go to my backplot, and it shows me that I'm drilling in and I have a bit of a chamfer, which is great. Okay, now I'm going to hit escape and go to my tap drill and check the depth of this drill. Now it also says that this is my total depth down here. So I'm going 1.104. Okay, and then it's rapiding over, and it's not doing a full retract into the very last hole, and then it's done. So those look good. We've got our spot drill and our tap drill done. Now we just need to tap them. So I can just copy this once again and paste it. I'm going to go up to my tool and select my tap. 1/4-20. We're going to specify this at 500 spindle speed, so not surface feet per minute. We have a feed per tooth of 50 thou. That's our pitch. So we're just going to tap this, and we'll go up to cut parameters and specify our tap function. Now our linking parameters, typically we can just go about the same as the drill because the point is going to be compensated as well, or if you wanted to go a little bit deeper, that's fine as well. I'll just leave it as is. So click OK, and now we've got a tap. So now if I wanted to backplot this, I would be able to see my tap, my drill, and my spot drill. So I'll back it up, and I'll turn on my stop conditions. Now I'm going to spot drill, and tap. And that gives me my chamfer in the one shot, which is awesome. I'm going to click close, and with this, I'm going to do my slot now. So I probably want to go into contour, and I'm going to select this chain at the base over here. If I select it over here, it's going to go the incorrect direction if I wanted to climb mill. So I'm going to, if I press R on the keyboard or press this button, it will reverse it so it climb mills. But I want to have it arc in at the middle of that line. So I want to have my base point selected like that. I'll click OK. I'm going to go to my tool and my 3/16 flat end mill. So if you have a 24,000 RPM spindle, that would work. If it caps out, make sure you drop your feed rate. So let's say if you capped out at 6,000 on a certain machine, you would have to back your feed rate down. Otherwise, you're going to end up breaking your tool. This is going to ramp the slot. Go to our cut parameters, and I'll specify ramp. I'm going to do a depth, and make sure my pass is at the final depth. And I want to go maybe, let's go 0.093. So that's half the diameter of the cutter. So if we're slotting, I like to turn off linearized helix because it doesn't work all that great on older machines. It spits out too many points and then it starts to jitter. So if you have a newer machine and it does points very well, linearized helix is pretty decent. I'm going to leave depth of cut off, turn my lead in, lead out to probably 10% on both, and then copy the options over to the other side. I'll go to my linking parameters, and I want to specify my total depth at minus 0.437. So I'm going to click OK, and let's take a look at this. So it's going to ramp it out and do a final pass at the bottom. So now that we've got those tool paths done, I want to copy them around 360 degrees. So what I can do is make sure you have these check marks on each. So if I just click on Toolpath Group, now I can just right click and go to Mill Toolpaths and click Transform, or I can go up to here and click Transform Toolpath. Now I want to rotate these around the center. I want to have all of these operations selected, and this group NCI output by operation or order, this is going to spit out a center drill, and then a drill, then a tap, then a slot, and then it'll do the same in that order on each quadrant. So that's a lot of tool changes. But if we do it by operation type, then that will do center drill all the way around, then drill all the way around, then tap and slot. So I'll click on rotate. I have my origin already selected. You can change it here. I'm going to do an angle between, and I want to do 4 angles of 90 degrees. So I'll click OK and generate my toolpath. Now if I have my button here selected, only display selected toolpaths, I click on this one, it shows me that I'm going around all the way. Now if I select on these, then this shows me that I have just those ones selected. Now you can do a couple of different options. You can specify only 3 rotations and use the existing operations, or what you can do is maybe ghost them. And then I like to put them in a folder. So new toolpath group, don't post. And then I'll take these and put them in here. We'll regenerate. So then when I go up to my back plot, it does all of the operations. So it's spot drills all the way around, drills all the way around, goes and taps, and then it slots out. Now I might want to also do a countersink on my slot here. So what I'll do is I'll create a new contour program. I'll select the same contour, and I'm going to select my tool, my 3/8 spot drill, call this chamfer the slot. I'll put this at like 40 inches a minute. And I will change this to 2D chamfer. I'm going to put this at 0.0313. When I have a bottom offset of 100 thou, you can specify it at 50 thou if you really wanted, but this should be sufficient enough. I'm going to make sure I've got 10% lead in, and my depth is going to be 0. So this is going to show me that my lead in and lead out is not going to violate anything. And now if I wanted to, I would put this at the bottom. So you just click and drag it to, so let's say if I wanted the spot drill, well, I don't want it at the bottom, so I want it at the top. So I would hold it and drag it to the spot right above it. Okay, So regenerate, and I'm going to add my parameters, and I'm going to add this. So we're going to close the don't post and verify it. So I have my spot drills, my drills, tab, slot, and then we got our chamfer. So I'll name this top side, and I have to create some lines on this part. So I'm just going to select contour, and I'm going to select these circles just like that. Click OK. And I need one more tool. So I'm going to go to Create Tool, and I'm going to pick a spot drill. We're going to call it 90 degrees, and we'll do, let's do 1/8. We'll click Next, set our surf speed, and we're going to click Finish. So this is going to engrave rings. I'll go to my cut parameters, and I want to set this to 2D, and I want to turn my compensation off so that it will engrave directly down the center of those rings. I'm going to set my depth at -0.01. So we're going in 10 thou. So click OK. And you see there's lead in and lead outs? That's going to affect what it's going to look like. So let's go back in and turn off our lead in and lead out. So if we just turn that off, click OK, now it's not going to escape our lines. So now we'll post it, and we'll just zip right through, and there's our lines. So now we're done. So we'll just click OK, and we're going to create a new toolpath group. And I like to click on machine group so then it doesn't go inside of top group. So this is going to be bottom side. And I want to go to my view, and I want to open up my planes. I'm going to right click on my top plane and duplicate it. And we're going to call this bottom side. Now I want to drop this by 1 inch exactly. And I also want to rotate incrementally either the X or the Y, it doesn't matter, because this is a round part. And I want to have it so that my Z is pointing downwards. So click OK, and then click this equals button to get everything to where it needs to be. So now if I go to my toolpaths, we are ready to do the toolpaths for the bottom side. I'm going to go into my planes and or levels and do another level, and this will be bottom wireframe. I'll disable my top wireframe and go back to my toolpaths, and I'm going to right click and go to top. Now as long as these are set to bottom side, you will be in the right spot. And I'm going to turn off these toolpaths, and now I want to create the inside pocket of this base plate. So I'll go up to my wireframe, click on circle center point, and I'm going to punch in 4.375 and press O. Click OK, set my 1.5 circle, and then press O. So now I have these two circles. So this is going to be used for my pocket. So what we've done is we've taken our part, we finished the top side, and we've flipped it over, and now we're going to rough out and finish. So let's go to our toolpaths, and we'll do dynamic milling. Now I want to do from stay inside, so that'll stay within this region, and I'm going to put an avoidance region of here, and my machining region here. So now if I click on preview chains, it shows me this donut of where it's going to machine. And that's exactly what I want, so I'll click OK. And we're going to go to our tool and select our 1/2 inch flat. And we're going to rough the pocket. So then we'll go to our cut parameters, and we're going to climb mill, and we're going to do a step over distance of 10%. Minimum toolpath radius 10%. And we're going to keep this down within 300%. We'll leave, let's say 10 thou on the floor and 50 thou on the walls. And then I'll turn off my micro lift distance and we're going to go 200 inches. Now let's go to our depth cuts. We'll turn that off. We'll go to entry motion and we're going to helix in. We're going to leave this as default. We'll go to our linking parameters and I want to specify this at -0.625. Check our planes, make sure it's set to bottom side and make sure coolant is on. And now we should have a toolpath generated. So now we've got this toolpath that opens up and clears out the stock that way. So now I want to create a finish pocketing program, and I'm going to select these two chains once again. I'll click OK, go to my tool, 1/2 inch flat, and everything is, let's type it, everything is good. So I'll type in finish pocket, go to my cut parameters, we're going to do a standard, and we're going to turn this to 0. So we're going to leave this on rough, and I'm going to leave my step over percentage at 50%, and I'm going to do spiral outside to inside, so then it doesn't throw the chips against the wall and then recut and then damage your cutter. I'm going to turn my entry motion to ramp and change my entry feed rate to feed rate and then auto angle. Go to my finishing. We'll leave this, let's set this to 2 thou, and we'll finish the passes only at the final depth. And we'll do a lead in and lead out, and those look good. We'll go to linking parameters, and we'll set this to -0.625. All of our other options should be set. And planes and coolant. We're good. So now I'm going to turn off this toolpath, and now this is going to do my finishing pocket on both the inside and the outside. Now I have my ramping starting way at the top where there's no material, so let's change that. Go to parameters, linking parameters, and we set this at -0.625, and we left 10 thou on the floor. So I just type in the plus 10 thou. So now it only ramps in 100 thou from that stock. So now that's going to be finished. And I want to make another hole that's going to be my thread mill. But let's chamfer these pockets first. So let's go to contour, and I'm going to select this one that way. So on the left hand side of this arrow is going to be where my cutter is. So then I want down here, the left hand side of the arrow is there. So then I get climb milling all the way around. I'll set my tool. This will be a 3/8 spot drill. Chamfer the pocket. Set this at 40. Go to cut parameters. Change this to 2D chamfer. We're going to leave this at 0.0313. We've got a bottom offset there, and we'll change this to computer or where, whatever you choose. Just keep it consistent. My lead in, lead out, I'm going to set this to 25% on both and copy the settings over. Now I'll go to my linking parameters, and this should be set to 0 because it does the math on it and it should give you what you need. So I'll click OK, and this now chamfers the remainder of my part. But if I were to backplot this, I could see, so we're punching our holes in, so the other side is already complete, and now we do our pocket, finish, and then our chamfer. And if you wanted to see what's happening between tools, you can just click on this color loop, and it shows you what's happening with each operation. Now we have, the only remaining thing is to open up this hole to the right size, and then we need to thread mill it. So let's click close, and let's create a new circle. Maybe go to levels and do a thread geometry. We'll close our wireframe or disable visibility, and we'll go to our toolpaths, and I want to turn off any remaining toolpaths. So let's go to our circle center point. Now I have a thread that's 1 inch 8, 12 UNF. So this is our major diameter. So then we have to do 1/12 to find our pitch, which equals 0.0833. The next step is to find out our straight depth for our thread for internal. So that'd be 0.5413 times our pitch, or divided by the number of threads per inch, would be 12. So we end up with 0.0451. So then we have our major diameter, and we subtract 2 times our straight depth, 0.5413 over n. And then we do another bracket and a bracket, and this gives us our minor diameter. So that gives us the innermost circle that we require for our internal thread. So if we multiply 0.045 times 2, we get 90 thou. And then we subtract that from 1.125. So we end up with 1.035, and that'll be our minor diameter. If we go back to Mastercam, 1.035 will be our minor diameter, and then we have to specify our major diameter, which will be 1.125. So we have to mill this out to the proper size, and we'll just use a contour toolpath. So it's already drilled and bored, so it could fit on a mandrel. Now I just want to click on my 1/2 inch flat end mill. We'll finish the minor diameter. We'll change this to 30 inches a minute. We'll go nice and slow, and we're going to set our compensation probably to wear, so you would adjust this on the machine instead of coming back into the software and doing it. We're going to click on lead in, lead out, make sure that's low enough, and then my linking parameters, I want to go a little bit past the thickness, or what you have is a chamfer, so whatever you prefer. Let's just go minus 1.05. That gives the cutter a little bit past the thickness of the part. And we're just going to do one pass because there's not a lot of material there, and it's just going to go around. So that is finished minor diameter. My next thing I need to do is do my thread milling. So if you just click on that expand gallery button, click on thread mill, and we're going to pick these outer hole, and it specifies your diameter right here. We'll click OK. We'll select our thread mill here. And might want to possibly drop this down. That's a little bit quick in the hole, but we're going to have to do some calculations with this anyways. So if you take a look at this sheet here, it gives us feeds and speeds calculations for our thread mill. So we would normally calculate our RPM with our surface feet per minute times 3.82 divided by our cutter diameter, which we've already figured out. Then we need to figure out our linear feed rate, and that'll be calculated with our chip load per tooth, which is 4 thou. We have our number of teeth, we have 6 of them, and we multiply that by our RPM. So we end up with a linear feed rate of 147 inches a minute. But we need to reduce this inside by using the adjust internal feed. So the reason we would want to reduce our feed rate inside of a hole is because the top portion of this thread mill, in between the shank and the flutes, is where it's going to be the most brittle. So it will break off at that point if you feed it too fast. So we'll have to adjust with our internal feed, and we'll use major diameter minus our cutter diameter, then divide that by our major thread diameter, and then take that calculation and multiply it by our linear feed. So 1 1/8 minus our cutter diameter, which is 745, we get 0.38. Then we divide that by our 1.125. So 0.38 divided by 1.125, and then we multiply this by 147, and this will give us 49 inches a minute. And we might as well just round up to 50 inches a minute. So going back to Mastercam, so let's change this to 50. Because 49.88, we're close enough. We'll plunge down. Let's go 25. Let's go 50. So we're going to plunge right down into the bottom and then make one full pass around in a circle, and that will cut our thread without having any deflection. Go to our cut parameters, and we have 18 active teeth. So the way we find that is 1.5 divided by our pitch. So we've got our thread start angle here. We can have it start at 0 degrees or 90 degrees, whichever you prefer. I'll leave it at the default. We have our overcut, which allows us to arc in. And then we have our taper angle, which we can cut NPT or British pipe threads with a standard thread mill. Compensation type, typically you want to have wear on, so you can offset this until you get your gauge to fit. You would set your ID thread for this one in particular, and we're going to leave those, and this will be a right-handed thread. We're going to go to bottom to top. Make sure you do climb milling because it will change. And the reason why we want climb milling is because the first couple of teeth tend to break off and wear out the most because they're doing all the cutting, and then everything goes and follows, and you would have to tap it again. We're going to go here to lead in and lead out, and I believe everything should be fine. We're going to go to multi-passes. And we're going to take one roughing pass, and our height is only 45 thou, so we could probably do a step over of 25 or 30 thou, but you just want to make sure you're not going to break that thread mill. So let's go do a little conservative pass here, and then we'll have 2 finish passes, and we'll set them at 0. You can do spring passes. I haven't had much luck with this, but using finish passes seems to work for me. So we can override the feed speed for doing our finish pass if we wanted to. And we have multi-pass linking where we can plunge or rapid or feed, and that's just in between each pass. We should be okay with plunge rate because we set that at 50. So we just want linking parameters, and we'll set this at 2" absolute. And 100 thou above, 50 thou above, the top of the thread is 0, and the bottom of our thread, well, we're going to go right through the hole. So we have a 1.5 inch long threaded section on that thread mill, so I'm going to go at least 2 pitch just to make sure it engages all the way. So -1, and then we can subtract 2 times 1/12 bracket, and that's an asterisk in there, and we end up going 1.167. So then we'll check our planes, and everything's good. We'll go to coolant, change that, and I'm going to turn off my finish pass, and this thread mill makes one pass, and then it starts again at the center and makes another pass, so it ends up doing 3 total passes. So if we run everything, so starting on the back side, so we spot drill, and tap, we do our slots, countersink our slots, and then do our engraving, and then we can flip it over to the other side, and now we pocket this out. So then we do our finish pass for our pocket, and then do our chamfers, clean out the inside bore, and now we do our thread mill. And with Mastercam 2022, you can see that the threads are actually put into the part. So there's our finished part. We've done both sides, we've done thread milling and transform operations. So I hope this helped you guys. Thanks for watching.